main thing. We have to save the energy by reducing the methane. That is very important. In India, around 12 teragram produced, and in the world is around 100 teragram produced. And the methane production is an unavoidable product of rumen fermentation. Water feed entered to the rumen. It causes degradation. The introduction for the rumen fermentation of carbon dioxide and hydrogen. So once the methanogenic algae are able to respond to increase the methane production. So this slide shows the methane emission of Indian livestock. So among livestock, buffalo produces more methane emission when compared to other livestock. Actually, in indigenous cattle, the methane emission around 100 gram per animal per day, and the exotic is around 150 to 200 gram per animal per day, and the small ruminants, sheep and goats, around 15 to 30 gram per animal per day. Another methane mitigation strategy, we have collected more number of feed samples to evaluate the methane mitigation potential of Tamil Nadu. So we have collected around 300 to 400 feed samples. So where we found that we have grouped in 6 categories, where we found that the crop residues producing more methane, around 4.18 ml per 100 million of truly digested substrate. And among the group, tree leaves producing very less methane. That is mainly due to the presence of plant secondary metabolites, mainly tannin, saponin, and organic acids. So based on the organic composition like organic matter, ether oxide, NDF, and methane production potential, we have developed a regression equation. That equation mainly can be used for to find out the methane production potential in all fields. So what are the factors influencing methane emission? Mainly internal factors as well as external factors. Internal factors like animal factors, species age, body weight, production level, methanogens, protozoa, and external mainly feed compositions. So that will increase the methane emission. So how will you reduce the methane emission? By the way of manipulating the rumen fermentation. So by doing various methods, by using propionate enhancers, inophos, supplementation of fats, sulfate, defonation, probiotics, so all will be able to modulate the rumen microbial population, thereby reducing the methane emission. So what are the possible methane mitigation strategies which are developed from Animal Nutrition Department, the NAVNAW? So based on the plant metabolites, by supplementation of organic acids and forage-based substrate approach like supplementation of Medicago sativa, Moringa oleifera, and essential oil supplementation, use of unconventional feed by using pomegranate fruit paste, balanced aeration, Saccharomyces cerevisiae supplementation, water-based multi-nutrient chew, supplementation of seaweeds. These are some of the studies where he carried out NAVNAW. So these were the foremost friendly feeding strategies, easily adopted at farming communities. So that were developed from NAVNAW. So one by one we can discuss. I will discuss. So first one is effect of supplemental organic acid on reduction of methane emission for dairy cattle. So here one of the best supplemental malic acid is malic acid. Supplemental malic acid. So 5 different experimental diet were prepared by adding 5 different malic acid level, where we found that 0.39% of malic acid was reducing methane emission around 15.69% when compared to control. So this is mainly used as a hydrogen sinks, mainly propionate precursors. If you combine with the hydrogen in the rumen, converted to propionic acid. This is an important feeding strategy, can be adopted in field condition. So this is the in vitro data. And based on the in vitro data, we have evaluated the in vivo in the indigenous dairy cattle. So it was provided in 5 animals, indigenous dairy cattle. So where we found that the methane was reduced by 3.26% when compared to control. And based on the reduction, there is a savings of energy. That energy can be utilized for increasing milk production around 2.3%, and the energy, the methane gram per kg milk production also reduced by 5.43%. So currently due to cost of organic acid, the organic acid should be supplemented through forages containing high level of malic acid. So mainly some of the forages containing high level of malic acid, mainly Medicago sativa, containing high level is around 0.5 to 0.8% malic acid, and fumaric acid is around 0.3 to 0.3%. So that can be included. That is a more promising strategy to reduce the methane emission. So where we have included 4 different level of Medicago sativa and prepared a diet, 4 experimental diet were prepared and evaluated by in vitro. So these are the chemical nutrient composition. So it contains malic acid, fumaric acid, and saponin and tannin. So once evaluation by in vitro, we found that 0.66 kg of malic acid, medica acid reduced the methane emission around 26%. The same level was evaluated by NAVNAW, where we found that the methane was reduced by 12.62%. From this, the energy saved around 167.24 kilocalories. That energy was used for increasing milk production by 9.15%. The cost also reduced by including medical sativa in the diets around 14.23%. So from this, it was found that the smallest strategies, so by adding medical sativa, that's definitely reducing the methane emission with increasing milk production, with reducing feed cost per kg. This is the simplest way of providing strategy to the farming community. Even the farmer having minimum number of animals, around 2 to 3 animals, this is the best strategy for the farming community. Next, by using Moringa oleifera, so where we have 5 different diets prepared with adding Moringa oleifera from 0 to 160 kg. So evaluated under in vitro gas production technique, where we found that 1.2 kg of Moringa oleifera reducing methane emission on 27%. The same level was validated by NAVNAW, so where we found that 9.62% of methane reduced when compared to control. From this 128.46 kilocalories of energy saved, that energy used for increasing milk production by 6.21%, and the cost of production also reduced around 24%. So Moringa oleifera, supplementation of Moringa oleifera is one of very good feeding strategy. In case of small farmers who are having minimum number of animals, is around minimum 2 to 3 animals. If you are having only 1 tree, can be supplied for 2 animals per day. This smallest range. Another studies we have studied at department the effect of supplemental essential oils on methane mitigation. So we are using garlic oil and peppermint oil. So it is around 0.65 microliter, 0.25 microliter of peppermint oil, reducing methane emission around 57%. The same level was validated by NAVNAW. So where we found that the methane was reduced around 12.53%. And the methane gram per kg digestible dry matter intake is also reduced around 11.86%. From this, the energy saved around 176.13 kilocalories. That energy can be used for increasing milk production around 10.43%. The cost of feed per kg milk production also reduced around 5%. So this is also one of the very good strategy that can be adopted on the farming community. And another one is very good strategy, effect of using pomegranate fruit paste. So currently we have more quantity of pomegranate, around 50% of pomegranates waste. So that can be used as a feed for dairy cattle. So it contains around 4.8% protein, and it also contains plant secondary metabolites, tannin and flavonoids around 2 to 3%. So based on the pomegranate fruit, it can be included in the basic diet up to 10%, 0 to 10%, and validated by in vitro. So where we found that 7.5% of the complete diet, reducing the methane emission around 55.38% when compared to control. The same level was validated by NAVNAW in indigenous dairy cattle. So where we found that the methane was reduced around 12.72%, and methane gram per kg digestible dry matter intake is also reduced around 10.39%. From this, it was found that 180.8 kilocalories of energy saved. So that energy may be used for increasing milk production around 16.36%, and methane gram per kg milk production also reduced around 24.99%, and the cost of production also reduced per kg around 16.18%. This is also very good feeding strategy, can be adopted at farming community. And another one is effect of balancing the ratio on reduction of methane emission for indigenous dairy cattle under field conditions. So we have studied one study under field conditions. So where we have collected the data from 50 animals from 3 days, 3 villages. So where we found that we have grouped the animals as high yielder, medium yielder, and average yielder and low yielder. So we found that the provided requirement is deficit, always deficit. So that has to be balanced. So once it is balanced, then we have analyzed the data on methane emission per gram per curve, where we found that the ration, balanced ration, reducing the methane emission around 24.41%, and the average milk production also reduced around 31.73%. So this is the simplest way. That the balancing ration and the field conditions, they are definitely fruitful for the farming community, because most of the farmers, they are not providing sufficient quantity of concentrate, so they are giving only paddy straw. Just providing additional concentrate or additional green fodder, definitely reducing the methane emission and increasing milk production. So another way of one more study we have conducted, the supplementing Saccharomyces cerevisiae probiotics. So under probiotics, these are the basal diet where we have given around 2.4 into 10 power 11 CFU per animal per day. So where we found that the methane emission per animal per day was reduced around 10%, and methane gram per kg digestible dry matter is also reduced around 12.45%. The energy saved around 143.46 kilocalories. That energy can be used for increasing milk production, and methane gram per kg milk production also reduced around 30%. This is also a very good strategy to increase the rumen fermentation, to reduce the methane emission, and also increase the milk production. And another one we have developed fodder-based multi-nutrient block, multi-nutrient chew we have developed. So this is the nutrient composition of multi-nutrient chew, where it contains urea, molasses, rice bran, soybean meal, and three fodders like Leucaena leucocephala and Sesbania graniculata around 30%, and produce 100 kg. In this we have prepared 1 kg multi-nutrient block. So that was evaluated by in vivo. So where we found that 600 gram in basal diet, that was reduced around 40%. The same level validated by in vivo. So where we found that methane was reduced around 14.59%, and methane gram per animal per day reduced around 15%, and milk production also increased by 5.8%, and cost of feed per kg is reduced around 8.86%. From this study, it was found that feeding a fodder-based multi-nutrient chew at 600 gram per animal per day with basal diet reduced the methane emission by 14.59% and increased the milk production by 5.84%. And one more study we have studied evolving feeding strategy to mitigate methane emission by using marine macroalgae. So we have collected more number of marine macroalgae, around 20 numbers. So we have evaluated the methane production potential. So finally one was selected, that is 2% Veleniopsis pachynyma. So that was able to reduce the maximum methane production potential. So that was included in the basal diet. So where we found that methane emission was reduced around 7.18%, and methane gram per kg digestible dry matter also reduced around 6.43%. And based on once methane reduction, the energy saved that can be used for increasing milk production around 5%, and methane emission gram per kg milk production also reduced around 4.59%. So from this it was found that 2% of Veleniopsis pachynyma around 200 gram per animal per day reduced the methane emission and increasing milk production. So we have more number of methane mitigation strategies studied that can be adopted in field conditions. Anyway, a strategy which is most effective, residue-free, environment-friendly, cost-effective, enhances sustainable production, and opt for farmers under field conditions has to be developed and recommended to the farming community. That is very important. So whenever you are thinking any feeding strategy that can be farmers-friendly, that can be useful for the farmers. Thanks.
Thank you, Dr. Bhartidasan. Well in time. Thank you so much. Compliments to you for a wonderful presentation. We are coming to the